All right, hey folks, going to jump right into it here today. Last Friday, what we did, I really liked. I liked the fact that you got a chance to look over your the answers from the previous homework assignment. I like the fact that you were able to submit it on Schoology, and I want you to do the exact same thing here today. So what I'm going to have you do is I'm going to have you look over the answers from last night's homework. I'm actually going to post that right here. If I can bring that up. Let's see here. Where did that go? There it is. Okay. So I want you to take a look at this. Make sure that you have the answers correct. You can pause it for a moment to look over that. And what I'm going to do is I'm going to go over all the ones that we did not go over in class. So if by chance you struggled with a problem, I want to take a moment and go over it with you and make sure that you've got it correct. Once you've checked it, you made sure that it's correct, you can go ahead and submit it in Schoology because I'll open an assignment there. I'm also going to introduce to you a couple of problems from the homework that I gave you yesterday in class. If you were not in class, everything has been posted to Schoology in a PDF format. You can do it on a hard copy, scratch paper if you want to, or if you want to print it off and use that, you can do that as well. Okay? So let's get into it here real quick. The homework from last night, starting with number 17 here. I can find here's a pencil, okay? How I do these problems, I'm going to do them nice and quick for you. 8 divided by 4 is 2, so I'm going to put a 2 right there. C to the third divided by c to the negative first. Remember, we subtract the exponents here. So if I do 3 minus negative 1, I get 4, because 3 plus 1 is 4. So I have c to the fourth. D squared divided by d squared, they are just going to cancel each other out. If I take 2 minus 2, remember that's 0, so d to the 0 is just 1. Again, they just cancel each other out. For the f's, if I take 4 minus negative 3, that's going to be 4 plus 3, which is 7. So in this case, 2c to the fourth, f to the seventh. Okay. Number 18, we could do lots of different things here, but ultimately in the end, we're raising it to the 0 power. What is anything raised to the 0 power? It is just 1. Okay. Number 9, what I notice in 19 is this. If I reduce the fraction 6/54, 6 goes into 54 9 times. 6 goes into 6 once. You could leave it as 1 over 9, or you could just leave it as 9. Okay. If I do f to the negative second divided by f to the negative second, remember we're taking and we're subtracting these exponents. So this is actually negative 2 plus 2. What does that equal? 0. Just like number 17 where we canceled out the d squareds, I'm going to cancel those out as well. I have g to the third divided by g to the negative fifth. So 3 minus negative 5 is actually 3 plus 5, that's 8. So I have g to the eighth. And h to the fifth divided by h to the third, 5 minus 3 is actually 2. And so I have h squared right there. Okay. For number 21, we have this right here. Now, I'm going to distribute that into the parentheses. Remember, we're multiplying that exponent by the exponents that are already there. So what do we have? Well, we have 3 to the third, and we have r to the third, and we have r to the fourth. Okay. Now, I'm going to do 3 to the third real quick. 3 times 3 is 9, times 3 is 27. Okay? R to the fourth divided by r to the third, 4 minus 3 is 1. So this is r to the first. If you want to put r to the first, you can, or you can leave it just like that. Okay? Number 22. I see the parentheses again. I'm going to go ahead and distribute this into the parentheses here. My denominator becomes m to the negative fourth, n to the negative third. My numerator is m to the negative second, n to the negative fifth. Okay? Now, if I take these and subtract them, negative 2 minus negative 4 is actually negative 2 plus 4, which is 2. So I get m to the second. Negative 5 minus negative 3. Okay? Remember, we're subtracting the exponents when we divide, is actually negative 5 plus 3, which is negative 2. So I get this. Okay? Can I leave it like that? Nope. So I need to send that n to the denominator. And that's our answer there. Okay? All right, it's number 23. Again, I'm going to distribute this into the parentheses. So this is j to the 4th, k to the negative 12th, over j to the 3rd, k to the 3rd. Okay. Now, again, I'm going to take these exponents and subtract them. So 4 minus 3 for the j's would be just 1. So I have j, or j to the 1st, either way. For k's, I have negative 12 minus 3, which gives you a negative 15. So this is k to the negative 15th. Now again, I can't have that, so in the end, it's j over k to the 15th. Okay, ooh, sorry about that. Got a little off track there. Again, that negative 15 drops down to the denominator. All right, now for number 25. Sorry for the sloppy handwriting there, but when you do it in pen, it doesn't make it nearly as clear. We're going to distribute that exponent to each one of those terms there. What that gives us is this. Negative 1 times negative 5 is positive 5. 3 times negative 5 is negative 15. Q to the 1st raised to the negative 5th is negative 5. Negative 2nd raised to the negative 5th is going to give you positive 10. Okay. Now we can go ahead and simplify with the Q's. We're going to subtract their exponents. We end up with 5 plus 5. And for the R's, the exponents, we get R, ooh, hold on, I wrote that wrong, didn't I? Q to the 10th. That's for the tenths for the Q's. And then the R's will be negative 25. Okay? Now again, I can't leave that, so I have Q to the 10th over R to the 25th. Okay? All right, for number 27, oh, get that paper up there. Okay. I've got this negative 2. It's going to go to every single thing inside the parentheses. Okay? Everything. So I have 2 to the negative 2nd, x to the negative 6, y to the negative 4th, and z to the negative 2nd. Over 3 to the negative 2nd, x to the negative 8th, y to the negative 2nd, and z to the positive 4th. Okay? So again, I'm just multiplying each one of these exponents by negative 2. Okay? And be careful with your negatives. Don't flip-flop back and forth. Make sure that you are able to multiply those correctly. Now, with these negative exponents here, what happens with them? Well, they flip, right? So I'm going to write this out. The 2 to the 2nd goes down. Well, what is 2 to the 2nd? That's 4. 2 times 2 is 4. The 3 to the 2nd comes up. Well, that's 9. I'm going to leave it just like that, 9/4. X to the negative 6 over x to the negative 8th. Well, if I take negative 6 minus negative 8, negative 6 plus 8 gives you 2. Okay? Y to the negative 4th over y to the negative 2nd, so negative 4 minus negative 2, or negative 4 plus 2 gives you negative 2. So we have y to the negative 2nd. And then for z's, we have negative 2 minus 4. This gives you negative 6, so this is z to the negative 6. Okay? Now again, you cannot leave it like that. So I want 9 over 4, x squared, y squared, z to the 6th. Okay? So hopefully that made sense how I worked that through to get the fraction I have there. Okay? Number 28. If we look at number 28, here's what it says. A lab technician draws a sample of blood. A cubic millimeter of blood contains 22 to the 3rd white blood cells. Unbelievable. And 22 to the 5th red blood cells. What is the ratio of white blood cells to red blood cells? Okay. So if I was to set that ratio, 22 to the 3rd over 22 to the 5th. Okay, what's that ratio? Well, what I would do, remember we subtract the exponents here? 3 minus 5 gives you negative 2. So I really have 22 to the negative 2nd power. Well, what is that? That's actually 1 over 22 to the second power. And if I work this out, this ends up being 1 over 484. Okay? So the ratio, what was that? White blood cells to red blood cells. Okay? Now, what's interesting about that, your white blood cell count goes up when you're sick. A person that has cancer, well, when they get cancer, their white blood cell is elevated. And so your bloodstream is infused with these blood cells, and that ratio is going to, or I guess it would go up, I guess, is a good way to say it. All right? 29. The number of three-letter words that can be formed with the English alphabet is 26 to the third. The number of five-letter words that can be formed is going to be 26 to the fifth. How many times more five-letter words can be formed than three-letter words? Okay? So five-letter words, 26 to the fifth. Number of three-letter words, 26 to the third. Okay? Now, if I subtract the exponents, this gives me 26 to the second. Well, what is 26 to the second? 676. There would be 676 more words that can be formed with the English alphabet. Okay? Now, not meaning that those words always make sense, but that's how many more words could possibly be formed out of that number of letters. Okay? All right, now to finish things off, I wanted to go to your Exponents worksheet that I gave you for tonight, and I wanted to look at just a couple of things to make sure that we are good with this moving forward. Okay? So the first thing I look at is this, number 7. I wasn't planning on doing this, but as I just looked at it, I'm like, you know what? We should probably talk about this one. In number 7, what has the negative exponent? Well, the negative exponent is just c to the negative third. It's not the 2. There's an exponent of 1 next to the 2. So as a result, I'm going to say that this is actually 8 c to the third over 2. Okay? Now, you can't leave it as 8 over 2 because 2 goes into 8 evenly, so I'm going to go ahead and do this, 4 c to the third. And that's going to be our final answer there. Okay? So again, the only thing that was the negative exponent was this part right here. And that's the only part that gets flipped, like we like to say in class. Okay? All right, now for the next problem, I had a couple of you ask me about this problem, and I said, no, we're going to do that tomorrow in class if we're here. Well, obviously if you're watching this video, you're not here. So I'm going to go ahead and work this out. Now the first thing I'm probably going to do, let me think here, how do I want to attack this? There's lots of different ways, that's the tricky part. I'm probably going to deal with this part first, and I'm going to put 2 y to the third over r to the fifth n squared. Okay? So just rewrite that with all exponents being positive. Now, when I have a divided by a fraction, this takes you back to probably 4th, 5th grade math, okay? When you divide by a fraction, what are you actually doing? You are multiplying by the reciprocal. So I'm going to put this as 2n, the reciprocal is to flip this, and then r squared y to the fifth, okay? Now, if we can multiply this straight out, things get a lot easier. We're almost done. So if I do this, 2 times 2 is 4, okay? N doesn't have anything to multiply with, so I'll do n and then y to the third. In the denominator, I have r to the fifth times r to the second. So when I multiply these, what do we do with these exponents? We add them. When you multiply, you add the exponents. So this is r to the seventh. Let's see here. We have n to the second. I should probably put that first. And then y to the fifth. Just trying to think of alphabetical order. So I'm actually going to do that. I'm going to flip that. Okay, so this is y. Let's do n to the second, r to the seventh, y to the fifth. Okay? Now, from there, we can go ahead and simplify things. Now, there's a 1 right here. Remember that. Okay? So if I subtract these, 1 minus 2 gives us what? Negative 1. So this is going to be this. 4 n to the negative first. There's nothing to go with the r to the 7th. And then I have y to the 3rd over y to the 5th. If you take 3 minus 5, that gives you negative 2. So I'm going to do y to the negative 2nd. Okay? Now we're still not done. We have a negative exponent. So what we should have is this. 4, let's see here, n, or n to the 1st, either way, r to the 7th, y to the 2nd. Okay? And that is going to be your, if you want to put multiplication symbols in there, you can, you don't have to. But that's your answer for number 16. Okay? 4 over n, r to the 7th, y to the 2nd. All right. Next part, scientific notation. Hopefully you remember this from your previous years in science class, but here's what's going on. A big number, well, first of all, scientific notation is always set up like this. You have a number multiplied by 10 raised to a number. Okay? Now, that number has to be between 0 and 10. So I'll put x right here for right now. And x has to lie between 0 and 10. Okay? If it's a small number, this one is a very large number. If it's a small number, it will have to lie between 0 and 1. Okay? Anything bigger than the original number, or is a large number, then it's going to be between 1 and 10. This number right here, oh, hold on. I think I just told you wrong. Let me back up just a second. In scientific notation, this number out in front has to be between 0 and 10. That's what it is, okay? This number right here can be any number, okay? Now, if it is a positive number, okay, I'm going to put y. If it is a positive number, think large, big number, okay? If y is a negative number, think small, little, okay? All right, so let's start with number 18. It looks like we have hundreds, thousands, million, billion, 5.1 billion, okay? So to turn this into scientific notation, I want you to start with your decimal point right there. Okay, and I'm going to count off from here until I get to a number between 0 and 10. Okay, so if I do this, check that, make it between 1 and 10. Goodness, trying to rush here too much. Okay, so if I do that, 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 places. So the number between 1 and 10 is going to be 5.1. I'm going to multiply that by 10. And then because it's a big number, 5.1, what did I say, billion? It's going to be a positive exponent. So this is going to be a positive 9. Okay? So again, the number has to be between 1 and 10. And if it's a big number, it's going to be a positive exponent. Small number, negative exponent. If I go to number 20 over here, starting right here, this is a small number, so maybe I should start like this. It's going to be a negative exponent. I'm going to move my decimal so that my number is between 1 and 10. So I'm going to go 1, 2, 3, 4, 5 spots to make it 7.5. It's between 1 and 10. And I moved it 5 spots, and we have that right there. Okay? Now, if I gather my calculator here, you can always double check your work with scientific notation by doing this. 7.5 times 10 raised to the negative 5th power. Okay? It gave me the scientific notation. Can I undo that? I don't know. Print maybe? No, it's not going to let me. Okay. I thought it would actually let me do that. 7.5 times 10 to the negative 5th. It's not going to let me. Okay. All right. For this one down here, first thing I'm going to check is this. It's a negative exponent, okay? So that means a real tiny number. So right now I have 3.2, okay, times 10 to the negative fifth. If it's a small number, I'm going to go 1, 2, 3, 4, 5, and I'm going to fill in all those spots with zeros. So 0.000032, okay? And again, as I look at that tenths, hundredths, thousandths, 10,000s, 100,000s, millionths, so 32 millionths, very tiny number, okay? As I look at number 23, I've got a positive value there, so this is going to be a very large number. So 4.081, I'm going to move it 1, 2, 3, 4, 5, 6, making this a very large number. So, okay, hundreds, thousands, million, 4,081,000. Okay, big number, right? Okay, so again, know how to work your scientific notation. On the back side, I'm just going to walk you through a couple of these. In numbers 25 to 30, remember we're adding exponents when we multiply. So in this case, 2 plus 3 is 5. So the question mark here is going to be 8 to the fifth. Okay. Down here, what plus negative 7 is equal to 11? Well, if I go ahead and put in 18, 18 plus negative 7 is 11. So c to the 18th is going to be the value of that first one right there. Okay. What plus negative 7? To finish things off, I think I have just number 40 down here. Okay. In number 40, I would multiply the coefficients together. It's all being multiplied together. So 6 times 2 is 12. 8 to the second times 8 to the negative first means to add the exponents. So 2 plus negative 1 is just 1. So I have A. Again, 2 plus negative 1 is just 1. So there's 2A to the first, and then you have B. Okay? So just some things I wanted you to think about. I appreciate you guys sticking with me there. Like I said, when you're done with the previous homework assignment, if you're good with that, submit it on Schoology, and I'll have that graded for you. And I'd like you to complete the rest of the worksheet that I gave you yesterday for Monday. Anyways, have a great weekend, folks. Be safe, and we'll see you later.